Hi friends, welcome to Class 10 Science Chapter 2 Acids, Bases and Salts. It will be a very interesting session and I will also give a lot of experiments and practical examples during this chapter. You can see the experimental setup that we will do today. And I have divided this chapter into 4 parts. In today's video, we will cover introduction to acid, bases and salts, and we will also study about indicators. And in the subsequent videos, we will be studying the other topics of this chapter. So let's start. So let's understand acids and bases with the help of an example. So consider that you are playing in your garden and suddenly a bee comes and stings you in your arm. Immediately, your arm gets swollen and you start feeling a lot of pain. Then you rush back to your home and scream for your mother, and your mother immediately rushes. She goes into the kitchen and she brings some powder and she applies that powder to your arm. And immediately after that powder is applied, after some time, the swelling reduces and so does the pain. Now, how did this magic happen? So when the honeybee bit you, so it injected a acid into your body which caused the irritation and the swelling. And when your mother applied that powder, which was baking soda and which is a base, it neutralized the effect of the acid. And as we know that acid plus base results in a salt, which is a neutral substance. So that's why your swelling disappeared. Similarly, you can also apply toothpaste to that wound. So then also the swelling will disappear. So now let us study the identification of acids and bases. So acids and bases can be identified by tasting them or by the use of indicators. So first let us study how we can differentiate between acids and bases by tasting them. So as we know that acids are sour in taste and bases are bitter in taste. Now have you ever tasted lemon juice? It contains citric acid and it is sour in taste, while bases are bitter in taste. But many of the acids and bases which are found in the laboratory, they are not very poisonous substances and we cannot taste them as they will lead to our death. So therefore, we have developed some substances which change their color when put in an acid or base, and these are known as indicators. So indicator is any substance which when put in an acid, it will have a different color, and when put in a base, it will have a different color. So now let us study the different types of indicators. So there are 4 types: natural indicators, synthetic indicators, olfactory indicators, and universal indicator. So natural indicators, as the name suggests, they are obtained from natural sources. And the most common example of natural indicators will be litmus. So do you remember how it is obtained? It is extracted from lichens. So litmus remains purple in color when it is in a neutral solution. So if you put litmus in a solution which is neither acidic nor basic, then its color will be purple. As you can see here, I have put litmus in a neutral solution and it is purple in color. Now there are 2 types of litmus: red litmus and blue litmus, and litmus is available both in solution form as well as in paper form. So another important natural indicator is turmeric. So once my mother made curry rice in lunch, and by mistake a drop of curry fell on my t-shirt. Then to remove the curry mark, I washed it with soap. And when I rubbed it with soap, I saw that the curry stain had become red in color. I was very astonished at how it has become red in color. So then when I read this chapter, I came to know that curry has turmeric in it, and soap, we know that soap is a base. So when I rubbed a base with turmeric, a color change take place. From yellow, turmeric becomes red. So from here we can make a conclusion that turmeric, that a base turns turmeric from yellow to red. Second, we have some synthetic indicators. So synthetic indicators are the indicators which are man-made, and two important synthetic indicators are phenolphthalein and methyl orange. So now we will study how color change takes place in these indicators when they come in contact with acids and bases. So now we will conduct an experiment to see how the indicators react with acids and bases. So in this experiment, I have taken two bases, magnesium hydroxide, and I have taken detergent powder, which is sodium hydroxide, and then I have taken a salt, common salt, NaCl, and then I have taken an acid, that is vinegar. And we will test it for four indicators: red litmus, blue litmus, methyl orange, and phenolphthalein. So here I have added some magnesium hydroxide in a test tube, and now I will add red litmus to it. So here you can see magnesium hydroxide, and here it is red litmus. So after a few seconds, you can see that it has become blue. So from here we can conclude that bases turn red litmus to blue. So now let's test it with vinegar, which is an acid. So here I am putting some drops of vinegar, and now I am adding red litmus solution to it. So you can see that the red litmus has remained purple in color. So this means that the vinegar has no effect on red litmus. So this means that acids do not change the color of red litmus. So now we will test it for blue litmus. So again I am adding magnesium hydroxide, and here I am adding blue litmus solution. So here also you can see that there has been no change in the color, and the blue litmus has retained its purple color. So this means that bases do not change the color of blue litmus. So now let's test it with vinegar. So I am adding vinegar, and now I am adding blue litmus solution. And now we will wait for a few seconds. So here you can see that after adding blue litmus to the acid, it has turned red. So this means that acids turn blue litmus red. Now again I have taken magnesium hydroxide, and this time I am adding methyl orange solution. So here you can see that on adding methyl orange, from orange it has become yellow in color. Now we will add vinegar to methyl orange. So here I have taken vinegar, and now I am adding methyl orange. So you can see that it has turned red. So this means that acids turn methyl orange from orange to red. So again I am adding magnesium hydroxide, and this time we will check it for phenolphthalein. So here you can see that it has turned pink in color. So now we will test vinegar and phenolphthalein. Phenolphthalein, which is colorless in color, I am adding it. And this time you can see that the solution has remained colorless. No change has taken place. So here you can see the entire experimental setup again. So now I am giving you a chart to memorize all the color changes that take place in the indicators. The third type of indicators are olfactory indicators. So these are the substances whose smell changes in acidic and basic medium. So now let's see the different types of olfactory indicators. So the first example of olfactory indicator is vanilla essence. So in acidic medium, it retains its characteristic smell, but in basic medium, it loses its smell. Second is onion. So this too in acidic medium, it retains its smell, characteristic smell, but in basic medium, it loses its smell. And third is clove. So in acidic medium, clove retains its characteristic smell, while in basic medium, this also loses its smell. So all these olfactory indicators in acidic medium, they have the characteristic smell, and in basic medium they have no smell. The fourth type of indicator is universal indicator, about which we shall discuss in the part 3 video. Stay tuned for the second part of this video, in which I shall discuss the chemical properties of acids and bases. The links to all the other parts of this video will be provided in the description box, and you can check them after 25th April.